everyone, I'm Luciana, Zigurat's Program Manager, and I speak directly from Barcelona. Welcome to the Masterclass BIM for Fabrication, Abu Dhabi Midfield Terminal Project Arches Cladding Case Study. Before starting the session, please make sure you can hear us and see us. And also, if you have any technical problems, please let us know via chat or through the question section, okay? Let's wait just one more minute to our attendees get in. Yes, Laura Castilla is saying that everything is okay. So, okay, let's start.
Can people hear me also?
I believe yes. Well, in any case, let me say welcome again to everyone to the Masterclass BIM for Fabrication Abu Dhabi Midfield Terminal Projects Arches Cladding Case Study of Zigurat Global Institute of Technology. And first of all, I would like to thank all of you for coming. And also, I would like to make a brief introduction for this Masterclass about the purpose of this Masterclass. So the objective of Zigurat is to transmit all our experience, our market experience in the field of BIM management for infrastructure projects. And because of that, we bring professionals that are influential and high qualified in the field. As is the case of our guest today, is Maria Souladaki. Maria Souladaki is Senior BIM Manager and also is BIM Lecturer at the Global BIM Management for Infrastructure Projects from Zigurat. Besides that, Maria is responsible for implementing BIM for fabrication, developing and coordinating bridges and tunnels BIM models, developing and coordinating structural BIM models, and also development of BIM execution plans from back.
Exactly.
Yes, thanks for your thanks that you're here, Maria. Thanks for coming.
Hello, everyone. Hello, everyone, and welcome.
And finally, I want to remind everyone that this masterclass is focused on the specific master, that is the Global BIM Management for Infrastructure project, and the master will start in May 2020. And that's it. If you have any questions, please write through the chat questions, and we will answer in the end of the presentation. And feel free to enjoy the presentation, Maria.
Yes,
it's all yours.
Okay, should I start? So you introduced, I am Maria Souladaki, I'm a civil engineer. I was the team leader responsible for developing and coordinating the 3D BIM models for arches cladding in Midfield Terminal Project from BIM Center Athens, together with BIM Center of CCC in Egypt and an on-site team in Midfield Terminal Project. So I will go ahead with the presentation. Let's see, first of all, the masterclass layout. We're going to make an introduction on this project with some general information. Then we are going to move to the scope of work of this specific project, the workflow that we used, the coordination that had to be made, the produce of work orders for fabrication, and finally, the installation process. Let's see now some general information. The location is in Abu Dhabi, United Arab Emirates. The client is Abu Dhabi Airport Company. The architects were KPF and the structural engineer is Arup. The size of the project is 735,000 square meters. The project cost was initially around $3 billion, and the main contractor is a joint venture of TAV, CCC, and Arabtech. Can you see my screen? Because I got a message.
Yes, we can see.
Okay. Just a moment, please. Now, some extra information for the whole project. The whole project will consist of 4 piers and a central processor. The central processor is the steel structure that will support the central processor roof is 319 meters at its widest point. And the roof of the central processor is composed of 18 curved steel arches. The biggest span of single arch is up to 180 meters, with around 50 meters in height and self-weights around 800 tons. So this is a huge construction. Now let's discuss about the scope of work. The scope of our work was the development of 18 arches and 36 backstage cladding and supporting system BIM models in level of detail 400. Our scope of work also was the coordination with the main steel structure, the chandeliers, we're going to see what was that, and the cameras of the project. And of course, to extract from the model the work orders, which included all necessary information for accurate fabrication of panels and the aluminum subframes. So you can see in this image the 18 arches. This is a render. They have dimensions from 65 meters to 180 meters length, and the max height, as previously said, is 52 meters. And also we had 36 backstays. These are the small arches on the sides, which had dimensions from 18 to 46 meter length. Now we're going to see what data we initially was delivered to us. We had the surface setting out model produced from the designers in Rhino. We also had elevations and plans that were showing the division of the panels and the dimensions of the panels. Of course, we had the details of the supporting system for the steel structure, how the panels will be supported on the main steel structure. And this is how we worked. We used the initial surface model and we extracted using a tool named Extract Face Edges. So I have to say here that the platform used for this specific project was Bentley's EcoSim Building Designer. And using the Extract Edges tool, we extracted the center lines of each side of the panels. So by this way, we created the edge lines model. After we created the edge lines model, we created the so-called green points. The green points were the points that were the edges of each panel, and they were created by a tool named Construct Array Along Path, using the dimensions provided in the 2D drawings, the dimensions that the subcontractor gave us through his drawings. So we created another model named Green Points Model, and this was the basis model for the automation tools we used. After that, we had to divide the work. So this is a key plan of the project. You can see these are the 18 arches in plan, and on the sides, the 36 backstays. You can see the smallest arches are here in the middle and the biggest arches here at the end. So the whole model was divided in the 18 arches and 36 backstays. So the total number of models to be developed was 54 BIM models. So what was needed to be created was, first of all, the cladding. The cladding consisted of curved panels, 3 sides of curved panels, and 3 sides of flat panels. And also, we needed to create the cladding supporting system onto the steel structure. So we had the flat panels subframe, the curved panels subframe, and also the top connection to steel structure and the bottom connection to the main steel structure. Since the scope of work was huge, our automation team created a set of macros using VBA for creation of the following. Macros that created curved lines for curved panels, macros for curved panels, for top panels, side panels, the mirror side panels, the top fixation, and the bottom fixation. And here we can see some of these macros that were created for this workflow. After that, we created a set of guidelines that was distributed to our team in BIM Center Athens that explained in detail how each member of the team will use the automation tools in order to avoid mistakes and also to accelerate our work. So through this automation process, we were able to create the flat panel and the subframe creation, the curved panel, and the curved panel's subframe. We have to emphasize here that by using the automation tools, the work time was reduced by more than 80%. But we also have to emphasize that apart from the use of automation tools, we also used manual adjustments, mainly for the top and the bottom fixation, to adjust to each element of the main steel structure. Now we're going to demonstrate a video. This is how we used automation to create the curved lines, which was the initial step to create the curved panels. You can see the green points on the screen. We had to fill in some values before running the macros. And then by selecting the points one by one with a specific order, of course, and running the macro, you can see how the curved lines was created. So why did we create these curved lines? These curved lines were created in order to create the curved panels by using another automation tool. You can see how quickly a curved panel was created using these curved lines. And we're going to show you another one. How the flat panels were created. Sorry. So by selecting again the green points and using specific macros that were created for each side of the arch, you can see how quickly the panel, the aluminum panel, and the subframe will be created. And this is a real-time creation of the panel. By using the same workflow, we created the side panels, You can see that also the fixation for the steel structure is created. And finally, the other side of the flat panels. For each side of the arch, a different macro had to be created. So by this way, we created the whole cladding of each arch and each backstay. And we have to emphasize also that each and every panel was different from the other, so it was unique. And this was the challenge of this project, that if we had to do it manually, it would take months to finalize it. And now, by using automation, we could finish a backstay modeling, a cladding modeling in 45 minutes, and an arch modeling in 4 to 5 hours. So this is the final outcome of the cladding. Next step was to coordinate the model with other subtrades. One subtrade was the main steel structure of China State Incorporation that was doing the steel structure. The other subtrade was the chandeliers that were hanging with tubes from the roof and were penetrating some of the panels and had to be coordinated. And also the cameras that were sometimes penetrating panels, and we had to make specific openings for the cameras to be accommodated in the arch or the backstay. You can see here the model. And how it is coordinated. This is the subframe of the panel, the bottom fixations and the top fixations. And if we turn on the main steel structure, you're going to see how everything was coordinated in order to attach to the main steel structure. And that was the final outcome of the BIM modeling process. After the BIM modeling process was finalized, we had to create the work orders, meaning to extract all the necessary information for the models for the fabrication process. So what we did was to create to depict in key in the arch that we're going to extract the work order. You can see here the plan and the corresponding arch. And by creating again and by using again the model and automation tools, we could extract sheets with all necessary information, dimensions for flat panels and curved panels. And this was done through the model and through automation process. You can see here the sheet with the internal work order, to which arch it refers, arch cladding 8. How many quantities of panels we have. For arch 8, it was 738 panels. We also extracted work orders for the subframe of these panels. You can see the datasheet with all the necessary information that was delivered to the factory for fabrication. And after that, after all the panels were fabricated in the factory, the site asked from us to assist them to the installation process. So they asked from us to provide them coordinates for all the panels in order to make it easier for the panels to be installed on site. So again, we used the model and we extracted lines with different colors. Each color represents a side of the arch, red for top, green for right, and yellow for left. and each line represents the start and end of each panel. Every line had a unique number at each start and end, which is a coordinated number found in a corresponding Excel file. So these were the corresponding Excel files. We had Excel files for the top panels, the right and the left panels with X and Y and Z coordinates. So this was very important for the installation process. So let's see how all this project was done through some pictures. Initially, we had the main steel structure. On this steel structure, the panels were put from the necessary workers. You can see here the installation process of the panels on the steel structure. And finally, these are pictures from how the panels look now. The Midfield Terminal project will open in some months. So this project has been finalized. And you can see the outcome of this process. This is it. You can see here the chandeliers and how they penetrate the panels. Everything that you see was coordinated from the BIM models. So you can see how BIM gave a plus to all this project and how we could accelerate the work and the quality of this model. And of course, we have to emphasize here that we also developed quality control procedures in order to avoid mistakes that would create delays and cost in the installation process. Thank you very much.
Thank you, Maria. Thank you for your presentation. I don't know, Isam is the academic director of the Global Masters for BIM Infrastructure Projects, and he's present in this masterclass. I don't know if he wants to comment anything, or if someone has any question, please let us know through the question channel or the chat channel. Let's see. Emmanuel Perez, he asks to, if you could, Maria, put in the first sheet, the first screen.
The first, the work order sheet. Can he?
Yes.
Okay, just a minute.
The information of the project, he says.
This is what he wants. Can you see it?
Let me check. Yes, I believe it is. Do you have any questions, Emmanuel? Let's wait.
I have to add here that the creation of the work orders was done by BIM Center in Egypt. The modeling process was done in Athens. CCC has 3 BIM centers in Athens, Egypt, and Palestine. So Athens was doing the modeling process, and the work order extraction was done in BIM Center Egypt. And we also had an on-site team that provided all the information in Abu Dhabi.
I have a question here, Maria, from...
I cannot hear you very well now. Yes?
How much time together?
Hello?
He asks, how much time did it take to create the macros?
I think Mr. Elapsi can answer this.
How much time did it take to create the macros?
Can Mr. Elapsi answer this question?
Hello.
Hello, Mr.
Hello, can you hear me? Yes, thank you so much, Maria, for the presentation. Amazing presentation. Thank you so much. The macros was created as initial version in 3 weeks. and a customization in another 2 weeks. So total, it's 5 weeks by one person.
Yes. And also we have to add here that we had to modify the macros because a lot of times the subcontractor was changing the design. Initially, we had to make panels with joints every, let's say, 8 to 10 millimeters, but then they changed the design and they wanted to do it 10 millimeters and then 12 millimeters. So all the work was not done only once. We had to do it over and over again, and automation helped us very much to achieve this change of design very quickly. So every time we had to modify all these macros and all the models according to the changes of the design.
Okay, thank you, Maria. Thank you, Isam. Edgar says no questions, just thanks. And Emmanuel Paris asks, the first sheet where it says all the information of the project that was removed. I think, but
the first...
he doesn't. Yes.
Just a minute, please.
Yes.
This? This is the first page with the general information.
I believe he didn't write anything else. Yes, he says yes. This page.
Okay.
Yeah, I think
these are information.
He wants to check it out.
Okay, these are information for the whole project. Our scope of work was the central processor, as I said, and the internal cladding of the arches, which was a major part of the whole building.
We have another question here in the meantime. I am from Egypt.
I can hear you very well again.
Good. He says, what is the name of the programs used? He says, what is the name of the programs used?
Hello, I cannot hear you.
Nice.
Hello? Hello?
Hello?
Yes.
Are you hearing?
Now yes? I can hear you. Yes, I can hear you now.
Sorry. I am from Egypt, he says. What is the name of the programs used?
The program used was Ecosim Building Designer of Bentley platforms. Now this software has been renamed in Open Buildings Designer, but at the time we did this project, it was Ecosim Building Designer. And for the macros, the team used VBA.
Yes. Thank you, Maria.
What are you doing, Alex? What? Who does that? Oh.
Do we have any more questions?
Yes. Can you hear me, Maria?
Yes, I can hear you.
Okay. Emmanuel asks, how much time did the project construction last?
The whole project? Mr.
Yes.
Lapsi, you want to answer this question? Can Mr. Lapsi hear us?
I believe yes. Isam, can you hear us?
Well, the general project was started in 2012, and it's supposed to open this year. There were a lot of some delays because the client made a lot of changes. So these changes affected the delivery of the project.
Yeah, Emmanuel also asks how much time before the beginning of the project the coordination has started.
How much time before the beginning of the project? For the specific,
Yes,
no, I believe that he speaks about the arch cladding, not the whole project. The project started by receiving the drawings from the subcontractor. This scope of work was done for a subcontractor that had to create the arch cladding. So after the subcontractor gave the scope of work to us, we started working with it. So
Yeah, now I can talk. Sorry, I had an experience.
Okay, Mr. Lapsi. Because he asked about the coordination, how much time before, but I think that the answer is that we started working as soon as we received data from the subcontractor.
For that task, yes, but for the project in general, we started working on this project 8 months before award. We were expecting that project, and as an initiative from CCC, being leader in BIM and digital construction, we decided to start our BIM involvement 8 months before the award. Hopefully, we were expecting that we would be one of the candidates for award, and luckily we were awarded the project. For the duration of the project is still under construction. It is in the final handing over phase. It started in August 2012, and hopefully it will be operational during 2020 or 2021 first. Hopefully when the coronavirus issue is finished.
Okay, thank you, Issam. Emmanuel says thank for the presentation and for the doubts solved. And I have another one here from Edgar. Yes, was the paneling integrated into 4D sequencing and or cost monitoring being used?
Can you please repeat, because I didn't hear the initial part of the question.
Yes. Was the paneling integrated into 4D sequencing and or cost monitoring being used?
If I may answer this, Maria?
Yes, you can answer this, Mr. Lapsi.
Yes. The arches were included in the 4D sequencing, not panel by panel, but assembly of panels, and cost of the arches were included in our workflows. It's general. We always have 5D for each and every component, including each and every panel. So the cost of each and every panel, from material, man hours of construction, and installment costs, was included in our workflows.
Okay, thank you. And the last question, I believe, from Christian Fernandez. Can you hear me, Maria?
Yes, I can hear you.
Okay. Christian says, first of all, thanks for the presentation and hoping everything is amid of this global crisis. Can you expand a bit more on the process of coordination between contractors doing the chandeliers and cameras and the challenges that came with for the BIM process?
Except for creating the model itself, there were other sub-trades that asked for coordination with our models. And these sub-trades were, first and most important, the main steel structure. that needed a lot of coordination with the models, because each and every panel had a subframe and fixations that had to be adjusted on the steel structure, and that was the most challenging part, because we used automation to create the fixations, but then we had to adjust it one by one manually on the steel structure. So the first step of coordination was with the steel structure, and the second coordination was with the chandeliers. These chandeliers were hanging from the roof and were supported, some of these, on the main steel structure. And in order for them to be supported on the main steel structure, they had to penetrate some of the panels. So we had to depict through the coordination in the factory which panels were penetrated from these chandelier tubes, and they had to adjust the panels by creating the necessary holes in order to accommodate the tubes. And finally, for the cameras were put inside panels. So for every camera that was positioned inside a panel, we had to make a specific opening that had also specific adjustments and steel plates in order to accommodate this camera and all its fixation in the whole arch. But definitely the most challenging part of the coordination process was the coordination with this main steel structure, because that was the bigger scope of the coordination. I hope that this answered his question.
Thank you, Maria. I have, I think, the last question now from Charlotte. How would you evaluate the use of BIM in this project compared to if you would have done the project without BIM? Was the project realized with integrated planning throughout the project?
Mr. Elapse, do you want to answer this? Or should I answer?
Yes, thank you, Maria. Okay, you can start with your answer and I will continue. You can start.
First of all, I think that without BIM, it would take, let's say, ages for this project to be finalized, because when you have an architectural challenge, meaning a project that has an architectural complexity and technical complexity, and you need to finalize it on time, and you have, for example, to create a whole arch had around 400 to 500 panels. And we had, let's say, 18 arches. We had around 12,000 panels. So if each and every panel had to be modeled manually and not by the use of BIM and the automation tools, I think it would take 4, 5, 6 times more than it did by using a BIM. Also, even in the installation process, the BIM was very crucial, since when you have to installate so many panels onto exact locations, by the use of BIM, we could provide all the necessary coordinates for this installation. So I think that BIM was very crucial for this project, and I don't think that it would be very easy to construct it by traditional means.
Excellent, Maria. Thank you so much for this input. And I think the example that Maria demonstrated very well here as one of the functions or one of the tasks that was supposed to be done in the project, and the amount of saving that was done using this technology and automation and digital construction workflows. This proves that without such tools, without BIM, without construction workflows, things would have been much more difficult than it is now. The project has a lot of challenges, construction, procurement, workflows, geometrical complexities, a lot of changes that could not be assessed or managed without having such platforms and such skilled resources who could manage all the different construction processes using BIM and other techniques that we have developed. So I will quote only the words from the project director, who said exactly, I don't know how could we do or build this project without BIM. This is the quote of the project director of this project.
Amazing, Issam. Very good, very good. Okay, guys, thank you very much, Maria, for your participation. Thank you, Issam, for your participation as well. And thank you, everyone, for your time and for attending. Okay, I have another question here. The last one, guys, we need to finish the masterclass. Charlotte asks, were all parties in the construction project, were all parties in the construction project able to handle BIM?
I got this, Maria, if you don't mind.
Okay.
Okay. Unfortunately, in this project, 85% of the stakeholders were not ready for BIM and were not equipped with the tools, skills, and resources to handle the BIM processes. Luckily, CCC, with its capabilities and resources, we have around 240 BIM engineers. We could manage to substitute the absence of skills with other subcontractors and other stakeholders and deliver on their behalf their scope. Otherwise, it would have been very difficult to do such a job. What helped us is our background and experience and vast amount of resources who are very well equipped with the techniques and background. As Maria said, we have around 240 BIM engineers, 3 BIM centers, and around we have 23 years of experience doing this kind of jobs. We have an automation team that could facilitate and empower our capabilities with tools that makes us more effective and more efficient. Of course, now, after 7 years of construction, all these stakeholders became fluent and understand the BIM process much better, which means that this project, the client and CCC managed to educate almost 120 stakeholders on BIM workflows and how to leverage BIM for construction. So I think the amount of benefits that the whole industry has gained is magnificent.
Thank you, Issam, and thank you, Maria.
Thank you.
Charlotte has an observation here regarding the integrated planning. She says it was not clear the answer regarding the integrated planning in this project.
Okay, if you don't mind, I'll take this, Maria, as well. Thank you, Charlotte, for the question. Actually, we have integrated planning in different stages of construction, and the client would not approve a schedule without being approved and evaluated through a BIM process, which means that each and every component of the construction must have been integrated with our construction schedule. This is the first point. If you talk about the construction of the arches or the arch cladding itself, of course, we did not link each and every panel specifically with an activity. Each group of panels or each assembly of panels were grouped and integrated with the relevant construction activity. This is if this answers your question. And this was demonstrated through monthly 4D construction sequencing. And the client used to approve that based on 2 factors. If the productivity of the relevant stakeholders is enough to meet the construction schedule, and if the construction schedule matches the client main targets. These are the 2 things that the client used to evaluate and validate the 4D sequencing. Does this answer your question, Charlotte?
Yeah, she's complementing here. Did you use integrated planning for the building project from the early start of the project and also throughout the project?
If you are talking about IBD, no, this project is not an IBD, it's not integrated planning project. However, we have integrated BIM with the planning process since day one. But the type of contract is not an IBD contract, if this is your question. It's a normal design build project. CCC with other two companies was the main contractor, and the design was done by others, as Maria has explained in the beginning of her lecture.
Okay, thank you, Isam. I believe we are going to finish the masterclass, guys. Yes, she says that is the point. Okay, thank you very much, Maria and Isam, for your participation, and thank you very much for all the attendance. We'll see you in the next masterclass. Okay, I will finish the masterclass.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
Have a nice evening. Bye bye.